How would we go about solving this equation right here? What is happening to the x plus 4? It's being square rooted. How do we undo a square root? Why can't we take the 4 out first? It's inside. It's a part of that, right? So I can't mess with the 4 first. So answer this question for me again. How do I undo a square root? I square it. If I square it, I have to square the other side as well. Okay? X plus 4 equals 144. It's exactly correct. Well, those kind of equations right there you've been solving since, what, 7th grade? Yeah? So subtract 4 from both sides. X equals 140. Is that correct? Are you positive?
No, it's not. It's the square root of 1. Now we have to take the square root.
How could we be positive?
Because since we...
How could we be positive that this is the correct answer? We could check it, right? 140 plus 4.
That's right.
144. What's the square root of 144? 12. Is this right?
Oh.
Yes.
I just figured we had to take it back to the...
It's all right. It's all right. Be nice. Why do I have to take away the 3 first? Because I'm trying to isolate the radical, right? This is the radical. If I'm trying to isolate it, I got to get rid of the 3 first. X minus 1 equals 6. Square it here and here. X minus 1 equals 36. So x equals 37. Is it correct? How could you know? Yeah, plug it in. 37 minus 1 is 36. The square root of 36. 6 plus 3. Then it's correct, isn't it? Okay. What do you want to do first? Are you sure you don't want to like distribute it in there?
Yes.
You're sure? I need you to be sure. Can I get inside of a radical? No. How do I get rid of the 2? Divide it. Very good. Square root of x minus 7 equals 4. Square, square. You can also talk today, apparently. X minus 7 equals? 16. Add 7 to both sides. X equals what? 23. Is it correct? How could you be sure? 23 minus 7. The square root of 16. 4 times 2. So is this correct? Yes. Yes, she did. What do you want to do first? If we're pretending this is a variable, which it kind of is, we subtract first, don't we? Okay, so minus 18 from both sides. 2 square root of x plus 1 equals negative what? Negative 12?
Oh, I put 16, that's why.
Okay. And then what? Divide by 2. Square root of x plus 1 equals negative 6. Square both sides? Okay. X plus 1 equals what? Guys, what's negative 6 times negative 6? 36. It's really like this, isn't it? Every time we're squaring, I'm squaring the whole side. Remember that? Okay. So now when I subtract 1 from both sides, x equals 35. Is it right? Should we check it? Okay. 35 plus 1. Square root of 36. Oh, it's not though. Nope. I'll tell you why in just a second. Square root of 36 is 6. 6 times 2. 12 plus 18 is 6. Is 12 plus 18 6? Then is this the right answer? So what's my answer? This is the only answer I got, guys. If this is not the answer, what's the answer? Correct. Here's the difference, okay? If I say to you, what is the square root of 25? Your answer is 5. If I say to you, what is the square root of 100? Your answer is 10. If I say x squared equals 100, and I put the square root sign in the problem to solve the problem, I have to say both of them. Okay? Who put the square root sign in this problem right here? We did. Then we have to assume the positive and the negative. Who put the square root sign in this problem? The problem did, right? So we have 5. Who put the square root sign in this problem? The problem did. It was already there. So when I plug this back in to substitute it, and I say the square root of 36, the square root of 36 is 6. That is all. Okay, you're kind of weird. So am I. It's all good. We are all weird. Okay, it's just one of those weird things in math that we have to put up with sometimes. Okay, since I put the square root sign in this problem to solve for x, I cannot just assume the positive. I have to have both there, the positive and the negative. But if I say to you, what is the square root of 100? That is 10. Okay? Any questions about that? So here's what I want to talk about. I want to go back to this point in the problem right here. Okay? If I go back to that point in the problem right there and not pay attention to my work, like I'm going to cover up the squares because that was my work to get to the next step, right? What do I have? I have the square root of x plus 1 equals negative 6, right? Guys, when am I going to take the square root of a number and ever get the answer of a negative number? Never, because this square root sign is already in the problem. So I could have actually worked to here and straight said no solution, because I can't take a square root of a number and get a negative. So if I give you a problem that says the square root of x plus 4 equals negative 8, there's absolutely no work that's necessary. You can just go straight to no solution. Okay? Now, what's common in every single problem that we've done so far? They're all square roots, aren't they? Are there other kind of radicals besides square roots? Okay. So if I give you a problem like the cube root of x minus 4 equals 11, when I solve this problem, how is it going to be different than when I solve these problems? Right, because this is a square root, so to undo a square root, I square it. This is a cube root, so to undo a cube root, I cube it. Okay? So I cube this side and cube this side. Well, what do I have left on the left-hand side? X minus 4. And what do I have left on the right-hand side? Good thing we have calculators to help us out, right? It is 121 times 11. I'm proud of you for knowing that. Mm-hmm. Do you see a pattern? Uh-huh. What would 11 to the 4th be? Close. No. Plug it in and look at it. This is just a little side conversation that has nothing to do with our work. Okay? 11 is what we started with.
Oh, it's like
When I square it, it's like that. When I cube it, it's like that. My guess is that this one is going to be this.
Yes.
And the next one, 11, 1, 2, 3, 4, 11 to the 5th power is going to be, 6, 1, 0, 5, 1.
Wait. What?
Would you do it and check my math? 1, 2, 3, 4, 5. Yeah, to 11 to the 5th.
Yeah, that's right. 16105.
Mm-hmm.
What?
Do you want me to show you or no?
Yes.
Yeah? Okay. We actually talked about this a little bit earlier when we did binomial expansion. We talked about Pascal's triangle, where all of the outsides are 1, and all these numbers, like this number is the sum of the 2 above it. This number is the sum of the 2 above it. This number is the sum of the 2 above it. When you're raising 11 to the power, it has a similar thing. So here's why this one was different, right? Because 1 and 4 should be 5, so that should be a 5. So you notice I wrote a 5 down there first, right? But 4 and 6 is 10, so I had to have the 0 and then kind of carry the 1 over here. But then 6 and 4 is also 10, so then I put the 0 here and then carried the 1 right here. It's not something I'm going to ever ask you to do, guys. I'm just showing you. I thought it was a cool pattern, and I wanted to show you today. It's okay. Your brain can be broken for now. That's fine. Again, it was just a situation that came up that I thought you would be interested in. It's a cool kind of pattern, and I thought you might want to see it. Okay, so up until here, it is Pascal's triangle. After that, it breaks. It's not Pascal's triangle anymore because we can't have a 10 as a digit. Okay? All right, so back to the problem. How do I finish this problem? Add 4. X equals 1, 3, 3, 5. Is it correct? 1, 3, 3, 5 minus 4? 1, 3, 3, 1. The cube root of 1, 3, 3, 1? 11 equals 11.
So then normally it's going to be right unless it's like a negative.
Well, let's do one because I want you to see it. I want to work through it. I want you to see what happens.
If you're doing it 3 times, then it would be negative again. Exactly. Because twice will be positive and another time will be.
Good. Good thinking. So let's work through the problem and so you can see what happens, okay? So here I cube both sides. I get x minus 4. Negative 5. This whole number, negative 5 cubed, is negative 125. That's right. Okay? So if I add 4 to both sides, I get x equals negative 121. When I substitute negative 121 back here, I get the cube root of negative 125, and the cube root of negative 125 is negative 5. Because we're thinking about what times what times what equals negative 125, and just like you guys said a second ago, it is negative 5.
Okay, so if it's an odd exponent,
Root.
if it's an odd root, then it'll work.
So if it's an odd root, like cube root, or 5th root, or 21st root, right? This will work, right? This will work if it's equaling a negative number. How else would we say it? It's of an even root. Like square root, or 4th root, or 68th root. Guys, we're ever going to do 68th root? No. No. This will not work if it equals a negative number. That was really great that you saw that. That was really great. Okay, because people don't always see that. So I'm very proud of you for that. Okay. Now, there is one problem in your homework that I haven't shown you. And I'm going to go ahead and I'm not going to do a whole problem like this, but I'm going to just kind of give you a starter because I want to give you a heads up about it, but I want to see how you react when you actually do the problem yourself. Okay? So here's what the problem is going to look like when you start out. X plus 4 equals the square root of x minus 6. I've got to isolate the radical first. Is it isolated? Is the radical all by itself? Yes. So how do I get rid of the radical then? Square it. Everything else, right? The whole side, right? So what am I going to get on the right-hand side? X minus 6. What am I going to get on the left-hand side? Oh, I was so afraid you were going to say that. X squared plus 8x plus 16. Because x plus 4 squared is the same as x plus 4 times x plus 4. And we have to distribute. Guys, every time that you say that the answer of this is x squared plus 16, a kitten dies. Every time. Every single time. Okay? So please remember that that's what this means, and you've got to go all the way here. Okay? How are you going to solve it from here? I'm not going to continue to solve it, but how would you solve it from here?
Well, you'd have to combine like terms.
You combine like terms and get it equal to 0. Okay? And then you would factor. Okay? Factor to find the solutions. Make sure you plug them back in, though, to make sure that they both work. Okay? Any questions about that? For the record, this one's not nice. It doesn't work really pretty. That's why I'm not finishing it. Okay? All the ones that you get, yeah, I want you to stop. I don't want you to try to solve this one because it doesn't work. It's not pretty.
But the steps we would do,
You would add 6 to both sides. You would subtract x from both sides and go from there. Okay? This one doesn't work. I just made one up for you to see what the steps would be here at the beginning. Okay? We've gone over factoring lots and lots of times, so you should be comfortable with doing that. And if not, I need to see you for tutorials. Okay? But again, you're going to get 2 answers, aren't you? You're going to get 2 answers, so make sure you plug both of them back into the original problem and check and make sure they both work. Yes, there is. There's one of these on the homework. That's why I went ahead and showed you this at the beginning. Okay? Any questions? Let me take that back. There's at least one of them on the homework. Okay? Any questions?